Our last field of study in this unit is going to be inequalities that exist in two triangles. And to begin this, we will look at Theorem 513, the Hinge theorem, or it's also known as the side angle side inequality theorem. It states simply, if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. And the reason this is called the Hinge theorem is you can think of it in terms of a door on a hinge. If you have your door or the wall of the house and the door that would be there, the door is partially open. Now take that same part of the house, the same door, open it further. If we were to construct a third side, making these triangles, that the larger included angle is going to be opposite the longer side. So this side right here is longer than this side here because this angle is larger than this angle. So we can use this to find relationships between triangles. Here I have two triangles, triangle LMN and triangle OPQ. Now LM is 4 units, PQ is 4 units, MN is 7 units, and OP is 7 units. So we have two sets of congruent sides. However, the included angles are not congruent. Angle M is 125 degrees, angle P is 78 degrees. So what would be the relationship that exists between line segment, or the length of line segment LN, and the length of line segment OQ? Well, because angle M is larger than angle P, we would have to conclude that LN is larger than OQ. And that's all that we get from the Hinge theorem. Now with this, you can also have an application into amusement parks. There's many rides where you are hanging from an apparatus, and as the machine spins faster, you move out. Well, the hinge point of your cables will always be the same distance from the center of rotation. So here we have our center of rotation, have a disc, strings hanging down. So this distance will always be the same, and the length of the string will always be the same. But as you spin faster and start moving out here, you are farther from the original location as we move along, and the triangles change. So that thrill of being further out and moving quicker is what the draw is on those machines. Next we have Theorem 514, which is the converse of the Hinge theorem, or the converse of the side angle side inequality theorem. This one states, if two sides of one triangle are congruent to two sides of another triangle and the third sides are not congruent, then the larger included angle is opposite the longer third side. So previously we were looking at that included angle not being congruent and the relationship between the sides. Now we're saying the sides are not congruent and it's a relationship between the angles. So the same hinge idea shows up. If the door is open wider, then that means the angle where the door meets the wall is larger. So how can we use this when solving a problem? So in this triangle that is shown, the given information is that the measure of angle MON is 80 degrees, so we will mark that, and that O is the midpoint of LN, so we have these two segments congruent. We need to prove that LM is the length of LM is larger than the length of MN. So how can we do this using proof style? Well, first, if we have the measure of angle MON equals 80 degrees. That's given. Next, we would have the measure of angle MON plus the measure of angle MOL has to equal 180. And that's your triangle angle sums theorem. From that, we could say that the measure of angle MOL is 100 degrees using substitution and the subtraction property of equality. From here, we can then move on to saying that MO, line segment MO, is congruent to line segment MO, and that is the reflexive property. So now we have the establishment of materials for Theorem 514. Because we have two sets of congruent sides and the included angles are not congruent, so by Theorem 513 actually, we would be able to say that LM is larger than MN, and that is Theorem 513, because the larger angle at MOL that compared to MON, the angles or the sides opposite would have to be larger as well. So when we are dealing with one triangle, we get these relationships inside. When we're dealing with two triangles, we can have inequality relationships that exist here as well. So use this information and proofs along with the other theorems and ideas that we've had so far, and we will continue to build on these as we move on.